Good afternoon, everyone. Looks like we have a full room today, virtually speaking, of course. So, if everyone's ready, we're going to get things started. I want to start by welcoming you to today's webinar, 7 Applications for Linear Heat Detection. My name is Gary Paul, and I'm the Regional Sales Manager for the U.S. and Canada here at Protectowire. I'm also a member of the National Fire Protection Association, Society of Fire Protection Engineers, and the Fire Suppression Systems Association. Today I'll be speaking to you about Protectowire's series of linear heat detectors, their application, and some common accessories associated to help provide some further insight into the products available and some of their effective uses. Before we begin, I do have a few housekeeping items to cover. First, today's webinar will be available on demand after the live session, and a copy will be emailed to all registered participants. Next, we have a live chat feature down below on your screen where you can submit questions you may have during today's presentation. You can also email any questions to info@protectowire.com at any time. Lastly, be sure to check out the polling questions on the bottom of your screen as well, and check out the additional resources provided in the Offer tab. So, without further ado, let's get started. We'll begin with a quick introduction. Protectowire linear heat detectors are a series of fixed temperature devices. Their unique design enabled their use in several challenging applications where conventional detectors simply can't reach. Except for fiber optic, Protectowire linear detectors are categorized as digital devices, which is simply to say the conditions of the device are either on or off. The first linear heat detectors were invented back in 1938 by Gerald Holmes, the founder and original owner of Protectowire, and has been listed with both UL and FM since the 1940s. Protectowire is best described as a continuous chain of spot heat detectors with the ability to sense heat or sudden increase in temperature anywhere along its length. A family of linear heat detection is available in several forms to meet a variety of challenges. To start, there's the PHSC series, which stands for Protectowire Heat Sensitive Cable. This is the product most widely used and the detector most relate to when they hear the name. Comprised of 2 steel conductors, the PHSC series can be integrated into any conventional or addressable system. However, there are limitations when considering equipment, which we'll get into in a few moments. Next is the PLR series, which stands for Protectowire Low Resistance. Same construction as PHSC, the PLR series adds copper-coated conductors to reduce the cable's overall resistance value from 0.185 ohms per foot, which is the standard resistance value for steel, to 0.058 ohms per foot. That's a roughly 2/3 reduction in resistance value. And in this case, lower resistance means longer runs. The most recent development in linear heat detection is CTI, which stands for Confirmed Temperature Initiation. Replacing the steel conductors with copper and constantan creates a Type T thermocouple, providing us the ability to measure physical temperatures at the location of the fault. Through the required CTM 530 interface module, we can now program the initiation temperature and compare it to the temperature at the location of the fault. Through this process, we can discriminate between a mechanical failure and an actual heat event. And lastly, we have fiber optic, which is widely viewed as the next generation in linear heat detection. Standard digital linear heat detection is considered a passive device, meaning it sits in a ready state, waiting for the fixed temperature to be achieved before it activates. Fiber technology, on the other hand, is an active system that reports real-time temperature profiles anywhere along its length, up to 10 kilometers. That's a little over 32,000 linear feet. And this is all done off a single fiber. And this can further be segmented or zoned into 256 unique partitions anywhere along its length, which is all done through software. As I referenced in the previous slide, integrating linear heat onto other manufacturers' control equipment can become something of a challenge, depending on some of the electrical values of the equipment we're connecting to. Linear heat detection is capable of being supported through any initiating device circuit, regardless of manufacturer. Where the challenge lies is the output value of the IDC and how much linear heat can be supported directly. As I mentioned before, steel has an inherent resistance value of 0.185 ohms per foot, and adding copper reduces this value to 0.058 ohms per foot. This slide provides a good illustration of exactly how much these IDCs can directly impact the zone coverage capabilities. In this example, we show two different addressable modules, the first with output values of 100 ohms and the second at 440 ohms. By dividing the IDC's output value by the resistance value of the detector, we get some surprising numbers. With the 100 ohm IDC, our calculations show we're able to support up to 500 linear feet of PHSE and almost 1,700 feet of PLR. We see similar limits in the 440 ohm IDC, but our lengths are longer due to the electrical properties of the module. Now, take into consideration that Protectowire conventional panels can support anywhere from 5,000 to 10,000 linear feet. You begin to see the challenges with presenting a viable solution with linear heat. And something of interesting note here, you'll notice that with CTI and fiber, these numbers do not change with the monitor module. This is due to the fact that each one of these series requires the interface module to be able to connect to the detector to properly function. To address the issue of the reduced zone sizes with PHSE and PLR, the PIM530 interface module was introduced. Depending on the manufacturer, the addressable IDCs can range from anywhere from 25 ohms to 1,500 ohms output. This output value directly impacts the total linear footage that can be supported. Through the PIM530 interface module, we can now tie into anyone's control equipment, conventional or addressable, and support up to 6,500 linear feet of standard linear heat detection. Other features include Class A or Class B monitoring, integrated alarm point location, communication to the main panel through Form C status relays or 4 to 20 milliamp outputs. We've also included a 64 event history file as well as Modbus serial communication. Like the PIM530, the CTM530 is specific to our CTI detector and a required component with every installation. The CTM530 acts as the brain of the CTI system, providing the false alarm discrimination by comparing the pre-programmed initiation temperature with the physical temperature at the location of the fault. If the temperature at the fault does not meet the initiation criteria, the system remains in a fault condition. In a Class A configuration, you maintain continuous coverage throughout the zone. In a Class B setup, you lose only the section beyond the fault. Everything up to and including the location of the fault remains active. As the leader in linear heat technology, we're constantly looking at areas to expand product capabilities. Two recent introductions are the perfect bookends to that endeavor, with the recent introduction of both our highest and lowest activating detectors to date, the PLR 500CR and the CTI 135 XLT. Both products address very specific needs within the marketplace. The PLR 500CR was developed to focus on applications that are constantly exposed to extreme temperatures, furnace work, kitchen applications, things of this nature. The CTI 135 XLT, along with its sister in our PHSC series, was brought about to address the extreme environments of industrial freezers and the ability to provide a pre-action system that will react before the sprinkler hits. Couple this with CTI technology and you have the perfect solution for the industrial freezers of all shapes and sizes. This brings us to applications. Within the special hazard community, linear heat detection is a niche element providing protection primarily in industrial settings, and is commonly installed to provide open area protection. Within UL and FM guidelines, it's listed in the same category as spot heat detectors with similar open area listed spacing, typically 50 feet per UL and 25 to 30 feet per FM. Given its unique construction, linear heat can also be woven in close proximity or direct contact with the item or apparatus being protected. This is typically referred to as proximity detection, and where linear heat really shows its versatility. What you're seeing here are some of the more common industries where linear heat is applied. Of course, within these industries lie a broad array of individual applications that are ideal for this technology. Through the remainder of the presentation, I'll explore some of these areas as well as some of the common accessories and installation nuances associated with each. Within the power industry alone, we can point to nearly a dozen different areas where linear heat is actively used. In cable trays, which can be applied in just about every commercial or industrial facility, we see linear heat providing early detection for overheating of primary cables. These are typically large, heavy gauge copper conductors carrying extreme electrical loads. Overheating and fire are both very real concerns, and in this example, linear heat is traversed above and in some cases in direct contact with the potential hazard. In the event of a fire, having detection capabilities this close to the hazard enhances your early warning system. Because of the unique shape and design, we can bring the linear heat detection as close to the areas being protected as needed or wanted. I also want to note the manner in which the detector is installed. Due to the nature and construction of linear heat, you must maintain a bend radius of 2.5 inches. Bends tighter than this run the risk of compromising the integrity of the heat-sensitive polymers. In this example, we see sweeping arcs traversing the cable tray. This can be installed both horizontally and vertically. It's required to support the linear heat detector every 5 feet. The Protectowire company offers an assortment of approved fasteners and splicing devices to facilitate installation for both standard and special applications. Protectowire approved fasteners are generally designed to lightly clamp the detector, which enables the tension to be applied progressively. This method is better than arrangements which apply a high tensile load at the end of each run or clamp and compress the sensor so tightly that the inner insulation becomes damaged. To ensure a trouble-free installation, only factory-approved fasteners should be used. The use of non-approved fasteners may physically damage the detector, thereby causing false alarms, and in some cases, void the detector's warranty. Shown here are some examples of common accessories used when mounting the cable trays. Each clip is designed or chosen to accommodate different material thicknesses in a wide range of applications, such as cable trays or storage racks and sailing joists. And here we see a great illustration of the HPC2 clip being utilized on a steel beam. Another common application within the power gen market is conveyors. In a coal-fired power plant, conveyors are used extensively. Some of the common issues seen here are bearing failures and belt slippage, both of which could cause overheating and potential sparking in the presence of coal dust. Designated as a classified hazard, the potential for fire is obviously much greater. Again, we're looking at proximity detection because we want to be as close as possible to these areas to detect and react as quickly as possible. In some cases, the conveyors are covered with a metal hood. In these areas, we can provide detection not only below in the area of the bearings and belts, but also above in the area where the material is being moved. In these areas, however, access to connection points to support the linear heat are limited. To accommodate long spans like this, you have the option of having the linear heat detector coupled with a messenger wire. Installing the messenger detector requires anchor bolts and turnbuckles to maintain the tension of the support cable and eye bolts to provide additional stability. As opposed to supporting the detector every 5 feet, you can now spread these supports every 25 feet. Instructions on the proper equipment and installation are readily available. And again, a great example of the versatility of linear heat in confined areas. Electrical compartments heat up very quickly. In transformer applications, we see linear heat being installed directly to the deluge system. In most cases, the linear heat detector will act as a pre-action or pre-alarm to initiate the alarm sequence. This is considered an integral aspect of the sprinkler's operation and should be located as close to the sprinkler heads as possible. In addition, or in place of installation on the deluge pipes, the linear detector can be applied directly to the transformer for early detection of overheating. Here, we illustrate the proper techniques to apply the detector. As you'll notice, we don't want to make any kind of penetrations directly into the transformer. Rather, we want to work with the appropriate cable tie mounts that can be adhered directly to the surface of the transformer with an industrial adhesive. We recommend Sikaflex 291. In addition to the close proximity, the linear detector's outer jacket options permit the installation in a wide range of environments from -60 degrees Fahrenheit or -51 degrees Celsius to as high as 392 degrees Fahrenheit or 200 degrees Celsius. Cooling towers can be a soupy and murky mess when they're in operation. These wooden structures withstand years of exposure. When they shut down for maintenance is when the concerns are the highest. Once dried, these structures quickly turn into a potential hazard. In most cases, we see linear heat detection being used and applied in several areas, including around the fan motor, gearbox, and down into the structure itself. Again, the primary objective here is proximity detection to the primary equipment. Due to the environmental challenges in these areas, we recommend there be no splices anywhere in the application. And you can see from these images the environmental challenges these structures pose. Our XCR jacket is a Teflon derivative that's well suited for a wide range of environments, chemicals, oils, even solvents. We also recommend stainless steel hardware throughout. And here we have an illustration of some of our installation accessories commonly used in cooling tower applications. We're showing our OHS coupled with our RMC3 L bracket, both made of stainless steel, which will ensure reliable support without the concerns of corrosion. Fixed and floating roof tanks are another common application, and one that we've seen significant growth in recent years, both domestically and internationally. Fixed roof storage facilities, as depicted here, are fairly direct. These are considered classified hazards and need to be installed in accordance with the proper guidelines. The use of intrinsic safety barriers and appropriately rated components is crucial. Once these guidelines are met, the rest of the installation is relatively straightforward. As you can see from the illustration, the linear heat is applied around the perimeter of the storage tank and around the relief valve. The end-of-line resistor, shown at the top of the tank, can also be positioned to make annual tests more convenient. The beauty aspect of linear heat is its simplicity in commissioning and in its annual testing. Per NFPA, linear heat is classified as a non-restorable fixed temperature device. As such, all that's required to commission or test is to short the detector at the end of line. As long as the system can register the alarm when the detector shorts, you know you have a fully active detection system. With CTI, this test can actually be taken one step further, and a heat test can be performed without damaging the detector. This is done through the available test probe, which will short out the detector and register the ambient conditions at the end-of-line junction box. Heat can then be applied to the test probe to induce an actual heat event, which will register on the module as an alarm and initiate the alarm sequence. Word of warning though, please be sure to disengage any relays or suppression systems to avoid any costly messes. In addition to fixed roofs, we also see a lot of floating roof tanks, as well as fixed floating roof tanks. In a floating roof tank, the roof forms a seal around the inner wall and will rise and lower with the level of the material it contains. The linear detection is installed in much the same way as a fixed roof, with a few exceptions. As you can see here, the detector is positioned just above the rim seal and around the perimeter of the floating roof. Like the cooling tower application, it's recommended to use support hardware that will withstand the expected environments, whether it be the cold and snow in the north or the heat and intense UV in the desert. Connection from the feed cable to the detection zone are achieved through a specially designed retractable cable that can accommodate both PHSC and CTI detectors and extend up to 99 feet. We've been through a few iterations of this design and finally arrived at the MS3091T. This is an extremely durable and resilient cable, well suited for some of the harshest conditions. The design was also enhanced to accommodate both PHSE and CTI conductors, which simplifies your options. One of the most popular applications for linear heat are warehouse storage and industrial freezers. In these facilities, linear heat is typically a component of the pre-action system. In a freezer, it's the primary releasing mechanism for filling a dry pipe system. When installing for in-rack detection, the detector should be positioned in the flue space at the same level or alternating levels with the sprinkler pipe. Typically, and as I've mentioned before, it would be recommended that the detector be fixed directly to the sprinkler if possible and permitted in your jurisdiction. It's still acting as an integral part of the releasing system. However, in a manually operated and active storage facility, the in-rack sprinklers take an incredible amount of abuse. This is one area where we recommend keeping the detector off the sprinkler pipe and as far out of harm's way as possible. With this level of activity, it's not a matter of if, but when the detector will be compromised. Of course, this is specific to in-rack detection. At the ceiling level, the opportunity for damage is greatly reduced. In this area, it would be advisable to follow the sprinkler pipes and attach directly to it if at all possible and permitted, again, according to your jurisdiction and your AHJ. To do so, we recommend double-loop pipe straps. These provide your installers the ability to cinch the cable tie to the pipe securely without compromising the actual detector. The first loop serves as your primary anchor to the pipe, whereas the second loop provides taut but loose support to the detector to avoid damage. For in-rack, we have a variety of clips available to accommodate the installation, including our WAW nylon clips, our OHS clip, and our newly introduced JD1 clip. The JD1 was recently introduced to provide installers an easier method of supporting and installing linear heat detection. Most, if not all, of the supports offered are a closed-loop format. These have been effective accessories for a great many of years, but are sometimes problematic when making repairs. To do so would require the removal of clips and then reinstalling. The JD1 design resembles a J-slot, with an open top and slightly narrowed opening. The open top allows for quick installation and removal without the need to remove or replace the clip, saving you both time and money. Aircraft hangars are another excellent application and well suited for any of the detection devices offered, including fiber optic. Due to the volatile nature of these facilities and the various fuels and chemicals present, a foam suppression system is required. At the ceiling level, linear heat provides the pre-action to initiate the foam delivery and is more economical offering when commissioning and testing are considered. Imagine the number of spot detectors required in a hangar that can accommodate several commercial or passenger aircraft. Based on listed spacing and ceiling heights, the number grows into the thousands. Now, consider the process needed to maintain these individual detectors on an annual basis. Great work if you can get it, but if you're looking for a quicker, more economical solution for both your team and your customers, then you need to consider linear heat. As opposed to hundreds, if not thousands of individual detectors, a large facility can be zoned and have the end-of-line resistor brought to a convenient location for testing. What you're seeing here is an image of a regional hangar here in Massachusetts with about 6,000 linear feet of detection broken down into 3 zones. As you can see, all that's required to test this system is a 6-foot ladder in about 15 minutes. We've even included an optional test button to make things even more convenient. In these facilities, false alarms are major issues, and where false alarms, discrimination is a huge benefit. Both CTI and fiber optic can provide these features to ensure a worry-free installation. We see water curtains being employed throughout airports as well. Passenger terminals are typically designed with an overhang to provide shelter and storage for vehicles and equipment. They're also designed with a lot of glass to provide views out onto the tarmac up above. Being directly below the passenger boarding area requires safety measures are in place to keep windows in the terminal from imploding during a fire. Water curtains are just one of the life safety measures employed. In these structures, the potential for fire is most prevalent in the area below the overhang. In this image, we see linear heat being applied directly above this area, along the lower ledge, and utilizing a messenger detector to span the distance, and providing a great transition around the corner. Again, our 2.5-inch bend radius is crucial. Taking the time to assure a smooth transition will make sure that you have reliable service. Road tunnels are a great application for any of the linear heat technologies as well. Where the detector is positioned above the travel lanes, they're high enough out of the way that false alarms should not be a concern, and it's well suited for the extended runs typically seen in these areas. However, some of the tunnels we see internationally can be as long as 7 miles plus. In a facility this large, fiber optic likely presents the most effective and versatile tool available. As we discussed earlier, fiber optic is an active detection system reporting real-time temperature conditions throughout its length. The beauty of having this real-time information is invaluable when determining the location and direction of the fire. Picture, if you will, being able to, in real time, tie the data into your HVAC and CCTV systems. As ambient conditions begin to rise due to increased traffic, the HVAC system can automatically kick on to open vents and increase circulation. In the case of a fire, the CCTV cameras are programmed to pick up the event, providing operators in the control room the ability to see what type of event is occurring. Is it a car fire, a truck hauling wood or chemicals? Where is the fire located and what direction is it traveling? This is all vital information that can be then reported to the fire department so they know what to expect and the best direction to take to address the situation. We've all read the stories of a construction project or renovation that suddenly caught fire. There are a number of reasons for the causes: hot works, improper disposal of smoking materials, or even cooking lunch in non-designated areas. In many cases, an active alarm panel is on site, but the smoke alarms and sprinkler systems are taken offline to avoid false alarms. This leaves the contractor and facility owners with the responsibility to provide 24-hour fire watch. In the Northeast, and specifically in the Boston area, linear heat has become the default for a wide range of construction projects throughout the region. These include schools, hospitals, parking garages, as well as commercial construction. With the unique design of linear heat, contractors are able to provide continuous detection without the need for a fire watch. Utilizing CTI avoids false alarms associated with accidentally hitting the detector and will only initiate under heat conditions. This is an image of one of the more prominent colleges in the Boston area. They adopted linear heat as their primary detection method during the renovation of one of their dormitories. The detector is installed down the hallway, in and out of the rooms, providing coverage needed to safeguard the facility while the other systems have been disengaged. When you look at projects like Notre Dame and losses they incurred both financially and emotionally, considering the importance of the building, know that there are solutions to help mitigate these situations. Firewatch is great, but it's costly. Linear heat works 24 hours a day and never takes a day off. Solar panels are a great source of energy. It's clean and activated by the greatest natural resource we have, the sun. However, a couple of facts remain. They can catch fire. We see reports of them almost daily. And in most cases, the only way of knowing that you have a fire is if someone driving by happens to report it. Beyond that, they're out of sight, out of mind. We see a growing concern from both building owners and underwriters on the best methods to address this concern. At this point, you can probably guess what I'm going to say, but I'll go ahead and say it anyways. Linear heat. Again, we're looking at a great way to explore the versatility of linear heat in some of the more unique applications. By running linear heat at the upper and lower sections of these panels, you can provide early detection to avoid costly and potentially catastrophic situations from occurring. We employ CTI on the panels on our roof, and have seen a few installations where the system alerted them to a small fire and dialed directly to the fire department. This is just a sampling of some of the more common applications we see, but is no way representative of the broad scope where it can be deployed. Some of the more unique applications include iconic towers, railroad trestles, interstitial spacing, historic covered bridges, which we just did a profile story on, and religious institutions, and the list goes on. If there's one takeaway I'd like you to gain from our time today, and I may have mentioned it once or twice, it's the unique versatility of this device to address some of the most challenging applications you may encounter. I want to thank you all for your participation. Hopefully the information provided was informative, and we look forward to any questions you may have. As a quick reminder, any questions that do come up can be emailed to us at info@protectowire.com. And also, don't forget to submit your vote on our polling questions and check out the offers provided under the Offer tab. Again, my name is Gary Paul, and it's been my honor to speak to you today. Be safe, be well.